Physically based rendering, or PBR for short, is the standard for materials in modern game engines. These types of materials can certainly give us more realistic results than the old school Lambert or Phong shading systems, but more importantly, they allow us to get predictably accurate results regardless of the environment or lighting. In Blender, we can build our own physically based shader that can be used for most any material. It doesn't take very long to set up, and it makes our lives much easier in the long run because it takes the guesswork out of shading. This means that we can spend less time tweaking values and more time focusing on creating awesome textures. Before we build anything though, let's take a minute to get familiar with what we mean by physically based, since it is a bit of a buzzword. You don't have to memorize all this info, but you do need to be familiar with the general idea. First, rendering works by firing rays of light from the camera into the scene. Path tracers like Cycles calculate how those rays bounce around just like light would in real life. When the rays hit a smooth and shiny surface, they bounce off in a straight line. When they hit a rough surface, they bounce off in all different directions. So when we talk about roughness, we mean how much of the light is being scattered in different directions by these microscopic bumps that are on every surface. The second thing to remember is energy conservation. A ray of light can be reflected, refracted, or absorbed, but of course not all at the same time since it can't be in two places at once. What this means for us is just that objects can't reflect more light than they receive. So rough materials will have dimmer and wider highlights, and reflective materials will have brighter and sharper highlights. This is something that we would have had to pay particular attention to in the past, but thankfully Cycles handles this for us if we set things up correctly, so we don't really need to worry about it too much. The third concept is Fresnel. Fresnel is the idea that objects appear more reflective the less that they are facing you directly. You can see this pretty clearly by looking at water. It's mostly transparent when you look down at it, but if you look from the side it's almost completely reflective. Everything has this Fresnel effect. The gradient is determined by the object's index of refraction, which is just a scientific value for how fast light can move through a material. How much of this Fresnel reflection we see is determined by the roughness of the surface, since all of those microscopic bumps we talked about earlier will make the light bounce in different directions. The last thing to keep in mind is that metals and non-metals behave differently. The color we see from non-metals, also called dielectrics, is from the light scattering underneath the surface. Some color gets absorbed and some bounces back out in a different spot than where it came in. Any light that bounces off directly does not change color since none of it is being absorbed on the surface. This means that dielectric materials will never be completely shiny, but the light that does bounce off the surface will not be colored. Metals, on the other hand, have a really tightly packed molecular structure, so all refraction is happening really close to the surface. Because of this, the reflections can be tinted. They still have Fresnel though, but in this case it's that all of the colors of light are more likely to bounce off at extreme angles, which means that the colors will become less tinted around the edges. So with those concepts in mind, let's start building a physically based material.